Here we're going to be writing an exponential function using some data points. We're going to calculate it ourselves, and then we're going to use the exponential regression feature on our graphing calculator to see if we got it correct. So first of all, looking at this chart, what is the value of C? It is whatever the Y value is with 0, so it's 500. And then our second point that we want to use is this X comma Y given here. It's 3 comma 650.83. So we're going from 500 to 650. We are modeling growth here. So when we solve for A, our factor, it should be a growth factor, which means it should be bigger than 1 if we do it correctly. So I'm going to write Y equals C times A to the X and figure out what A is. So I'm going to replace Y with the Y value of the point, 650.83. The C value, the initial value, is 500. Then we are trying to solve for A, and we're going to raise it to whatever the X value is. In this case, it's 3, which is nice because we're solving for the base A instead of solving for an exponent. Solving for an exponent requires us to use logs to solve for an exponential, but here we're solving for a base. So we're going to use a square root button or a cube root button. It could be a fifth root button. We're not going to have to use logs though. So first of all, I'm going to try to get A by itself by dividing both sides by 500. So that it's no longer multiplied by 500, which is going to give me 1.30166 equals A cubed. And I want to get rid of the cube root, so I'm going to use the math button on my calculator. I might have to scroll down to option 3 or option 4. One of those options on your calculator should have a cube root, or it should have an X root so that you can change the value of the root. We want to take the cube root of both sides so that we can get A by itself is going to be the third root of 1.30166. And we want to round to 2 decimal places, so A is going to be 1.09. And I can use that to write my function, Y equals C times A to the X. So it's going to be 500 times 1.09 to the X. That looks perfect. We knew it was growth because we went from 500 to 650, so we're multiplying by 1.09. Bigger than 1 makes it so that it's growth, and that 1.09 says maybe it's not growing super fast, which makes sense because we only went from 500 to 650. But let's figure out what is this growth rate going to be. Not decay because it's not less than 1. We're going to find the growth rate by figuring out how much bigger than 1 did we get. So we're going to do 1.09 minus 1 to figure out how much bigger than 1 we are each time. It's 0.09 bigger, and we're going to multiply that by 100 to make it a percent. We have 9% growth rate. You might be able to tell that right by looking at the number. You don't have to show this work, but if you can't tell by looking at the number, here's the work you do. Figure out how much bigger it is than 1 by subtracting 1. And multiplying it by 100 to make it a percent. Lastly, I can check that I found the formula correctly. I'm going to use exponential regression in my calculator. So I'm going to hit Stat, and under Edit, I'm going to type L1 as being these X values, 0 and 3, and L2 are going to be the Y values, so 500 and 650.83. And then if I hit Stat again, I can go over to Calc and scroll all the way down to where it has exponential regression. So I'm looking for that EXP regression and just hit enter a bunch of times, and you should see that this formula is going to match what your calculator says it should be between those 2 points. So you just enter in those 2 points to see if what you found manually matches what your graphing calculator says is correct between those 2 points.